Hello everyone. In this lecture, I will discuss about inverse Z transform. The first problem is find x of n if its Z transform x of z is given by x of z equal to log of 1 plus a into z inverse 1. Here ROC is modulus of z is greater than modulus of a. Now in the solution, here x of z is log of 1 plus a into z inverse 1. The differentiation property states that z transform of n into x of n is z into ddz of x of z. Now z into ddz of x of z equal to ddz of x of z. That means log of 1 plus a into z inverse 1. If we perform this operation, mathematical operation, then we find ddz of x of z equal to minus a into z inverse 2 divided by 1 plus a into z inverse 1. Multiplying both sides by z, we can get z into ddz of x of z equal to ddz of x of z. Minus a into 1 by z plus a. Let this is equation 1. If we consider the z transform of minus a to the power n into u of n, then we can find z by z plus a. Z is as modulus of z is greater than modulus of a. That's why here we used right-sided sequence. Right-side sequence means u of n. By using shifting property minus a into n minus 1 and into u of n minus 1. Here shifting value is minus 1. If we consider the z transform, then we can find z inverse 1 into z by z plus a. That means z inverse 1. By z inverse 1 into z transform of x of n, that means x of z, and x of z is z by z plus a. So finally we can get find 1 by z plus a, taking inverse z transform in both sides in equation 1. If we consider the right part, then the inverse z transform is n into x of n. And if we consider the right sided part, here is the left side part, and if we consider the right sided part in equation 1, then we can find this is inverse z transform. Finally we can get minus a and inverse z transform of 1 by z plus n, and this is minus a to the power n minus 1 into u of n minus 1. or x of n equal to 1 by n into minus a to the power n minus 1 plus 1. That means the final answer is this is the answer. Now second problem is find x of n if its Z transform x of z is given by x of z equal to log of 1 by 1 minus a into z inverse 1. Here modulus of z is greater than a. Here x of z is minus log of 1 minus a into z inverse 1, and ddx of x of z is one by 1 minus a into z inverse 1 into z inverse 2, and multiplying both sides with z, we can get z into ddx of x of z equal to minus z inverse divided by 1 minus a into z inverse 1. And by solving this, we can find z by minus z by z minus a. As modulus of z is greater than a given in the questions, so we have to consider the right-sided sequence, and here we used u1 because u1 is a right-sided sequence. If we consider the z transform of a to the power n into u of n, the answer is z by z minus a. The differentiation property states that n into x of n, the z transform is z into ddx of x of z. Taking inverse z transform at both sides of equation 1, here the equation 1 is, if you consider the left side part, the inverse z transform is inverse z transform is n into x of n. That's why for this left sided part, the inverse z transform is n into x of n, and for the right sided part, the inverse z transform is e to the power n into u of n, e to the power n and u of n. And as the minus existence here, so we put minus here. So the final result is x of n equal to minus 1 by n into a to the power n into u of n. That is the final answer. The third problem is, given that h of z equal to 1 minus z inverse z to the power minus 4 divided by 4, find h of n. That means inverse z transform of h of z and h of e to the power j omega. Here h of z equal to 1 minus z inverse to the power minus 4 divided by 4. We can reorganize this 1 by 4 minus 1 by 4 into z to the power minus 4. Taking inverse z transform of each, them separately, for this part the inverse Z transform is delta of n, 1 by 4 into delta of n, and for this part Z to the power minus 4, the inverse Z transform is delta of n minus 1. That means h of n equal to model inverse Z transform of first part and second part. That means 1 by 4 into delta of n minus 1 by 4 into delta of n minus 4. Now the second question is h of e to the power j omega h into e to the power j omega equal to 1 minus e to the power j into 4 omega divided by 4. Here typing mistakes. 4 h of e to the power 4 into j omega. One minus e to the power minus j into 4 omega divided by 4. We know that e to the power j theta equal to cos theta minus j into sin theta. Here theta equal to 4 omega. That's here's the final answer. Here's I ending my lecture. Thank you.